Okay, so we're doing our smoke today on a building that's collapsing. And that's basically going to be via this rigid body simulation that we already have a cache for. Either because you did it yourself or because you're using this one. So drop down a node, we'll call it rigids, like so. And I'm going to drop a file sop to read in at least, well, let's talk about it. What are we reading in? If I go to rigids, you can see there's a proxy file, a high-res file, and then a whole bunch of files in here. That's the actual simulation data. So let's start with the proxy. The proxy is the building. It's the actual pieces of the building. But obviously they don't move. It's just the one file. To move them, we'll need to drop another file sop down. And we'll point to that simulation data now. Make sure show sequences as one entry is on. Click it so that basically the frame number gets replaced by the $F. Look at that. It's just a bunch of points. Now what these two things have in common is that they both have a name attribute on the points. And you can see they look like this. It's like material and then like some kind of identifying information and then finally just some numbers because there's a lot of pieces in here. But again, the points have it too. So we can use that to sync them up. So put a transform pieces, and in the geometry to transform, take this. Transforming means we want to move it. Meaning we want to move it in space, we want to rotate it, we want to scale it. And then this says the template points. So put the points one in that. And that's it. I literally don't have to do anything else. It uses that name attribute to move the one things to the other. These points have orientations, which is, rotations. It has the regular P position that we're used to, where it is. The name we said, the pivot is what it rotates around. The scale is how big the pieces are, in case any of them aren't just at a regular scale. And then V for velocity and W for angular velocity, the way it spins around itself. So it's just a bunch of data, and it allows us to not have to store all of the geometry in their rotations on every single frame. So orders of magnitudes less data, and it's just faster anyway. So that's what that's doing. Now these pieces are the proxy ones. They're pretty angular and low resolution. You can see these polygons, they're just flat. It's just very simple shapes. That's what we wanted when we did our rigid body sim originally. And what we'll want again for this lesson too, for when we're doing at least our particle collisions, probably all of our collisions. At any rate, go here and let's go grab the high res, the corresponding high res one here. The high res, as you might guess, is essentially the same pieces with the same names. So we just need to have them get moved into the same locations in the same way. So watch what happens. Ta-da! It's essentially the same, there's just more resolution to it now. The shapes are more interesting. So again, if I look at any given one of these, just take a good, well, I guess that works. Now let's just take a good look at it, click on this, and you can see, again, simple, high res. Something we talk about quite a bit in Rigids 2 where we made this. And the last thing I'll say regarding the nature of this, because it will come up, is that these are packed pieces. Now this is a volumes lesson, so the odds are is that you've come down from volumes 1 to here, perhaps, and you don't know what packed pieces are. I would strongly recommend that you take a break from this lesson and go watch the free Applied Houdini Rigids 1 Fundamentals. We get into it in the very beginning of the lesson, and it will explain everything about what packed pieces are and how they're different from regular geometry. I will say very quickly, though, that if I take a piece and I look at it, like let's say this, I'm going to delete it. You don't have to do this, but I'm saying delete non-selected just so we can look at it. You need to understand what packed pieces are because they will look weird to you otherwise. And they'll actually look weird to a lot of tools that we're going to use. It says one point, one primitive. It is one packed fragment. But when you're looking at this, you're like, well, obviously it's not. I see lots of polygons here and lots of points. But they're not. They're not really there. We see them in the viewport because a packed piece stores inside of it primitives and points. If I do an unpacked, in fact, we can now get back to what you're used to seeing. 11 polygons, 18 points, and there they all are, and I can move them around and do whatever. But that's only because they're unpacked. When they're this form, there's just really one point, and it's in the center of this, so it's kind of hard to see. It's just one point, and it is a reference to this geometry. And that's all I'll say without, because I don't want this to take too long. Go watch Ridges 1, or if you came from Ridges 2, you obviously know this already. So, moving on from that, we have a bunch of glass here. Glass is hard to render in Mantra. It takes longer maybe than it should, maybe because it's too accurate. I don't want to waste literal render time on that in this lesson. It'll be hard enough to render all the smoke. I don't need refraction and smoke. So what I'm going to do here is, remember when we looked at these names, the names have the material first. Well, a bunch of it is glass. Let's just get rid of the glass. So we'll say any name attribute that starts with glass and then has anything else. Change this to points, and we actually move the display onto it to see that result, and there you go. It's gone now. Like so. If we had tried to do it here, where we just deleted the points, the glass points, they would just stay where they were. So we can't do that. So put it here. And let's also right click and hold, go to Actions, Create Reference Copy. Do the same for the high-res geo, because we don't want the glass to be rendered. This is actually one that's going to get rendered. And seeing as we're not rendering it, I don't want it to be collided with either, which is why it's in both. That's cool. What is that? Get out of here. So that's pretty much right. The last thing I want to do is let's just make a flipbook to make sure we have the feel of it right. Put the mouse over the viewport, press D, go to background, and let's change the color scheme to light for a minute so I can actually see these pieces show up on the background better. Let's do a flipbook and see what it looks like so far. And there you go. So it all works, obviously, no popping or weird stuff. The thing I would say, though, is we're going to talk a lot about how to make this look good. And making a thing looks good means art direction. So I would say right off the bat, what is the feel of this? We have a lot of pieces that start here and they fly out. Now we're not going to change the rigid body sim at this point. It's just a cache after all. But the idea is that there's an explosion here, and these pieces flying out will be like, spikes of smoke and particles. So this guy over here, this is not what this is about. It flies out for some reason. I guess he was just loosely attached to the building and it broke off somehow. It looks very silly. This second piece I care less about because there's lots of things at that point. But at this point, this is going to be a distraction to have a smoke column just shooting out to the left for no reason. So let's just delete that one, or delete both of them if you like. There it is, we see it. I'm going to press S, and I'm going to press, so that's in selection mode. I'm going to press 2 to make sure that I'm in points mode. Then I'm going to click this thing up here, select groups or connected geometry. And then I'm going to go click the gear and go to name. It's a lot of steps, but what that gets us is all those names that we saw before. And as we select things, or we hold our mouse over them here, you can see it's selecting them by their name. So that way I can select this. You can see the name is there. Select it, press delete. And now our blast will be in terms of deleting that name. Much like how this was deleting a bunch of things that started with glass, this is deleting a specific thing that has a specific name. So take that, actually move it above here, so it's already deleted. And again, do actions, create reference copy. We don't need it to render it either. Cool. So as you can imagine, if we actually scrub through this now, that was weird. If we scrub through this now, we don't see it anymore. We see that second one, but I don't care about that one. So to finish up here, let's put a null for high res. This is what will be getting rendered later on. And we'll do a null, whoopsies. We'll do a null for, what's happening? The proxy. This won't be rendered, but we will use this for various collision-related things. Another nice little bonus as we finish up this chapter is put an output after that. The output is a specific node with this cool flag on it. It's kind of like a regular null, but it means that no matter what I have selected in here, like let's say I was doing something here, when I'm outside of it, the result will still be that node, which is nice. Because many times in this lesson, I'm going to be like working on particles or whatever, and I'm going to want to see it with the building also, or at least the proxy representation of it. And now I can just turn this on and off whenever I want, and I'll see it, no matter what I had left selected in here. So that's it.